Okay, hi everyone. Today I'm going to actually carry out a simple experiment on the principle of moment. Alright, so basically what we have over here is we have a beam and then we have a weight over here, right? So if I were to place one of the weights at the number 3 unit mark over here, how will the beam turn? So it will turn in the clockwise direction, right? So now in order for me to actually ensure that the beam is balanced, I need to apply an anti-clockwise moment. So an anti-clockwise moment can actually be created by two ways. Number one, I can actually place an upward force over here. Number two, I can actually place a downward force over here, right? So there are two ways that I can do it. So if I were to actually use another one of these weights over here, I will have to actually place it at the number 3 mark over here, right? And when I place it at the number 3 mark, whoa. Alright, there you go, right? It actually balances. Okay, right. Okay, so now let's make it a little bit more challenging. What I'm going to do is I'm actually going to remove this one. Okay, and I'm actually going to place it at the number 5 mark over here, right? Okay, so maybe now you can try and see if I want to rebalance this beam over here just using one of this, using one of the weight. At which number should I place it, right? Okay, so let's try. Okay, maybe I can try putting it at 7 first, right? So when I place it at 7, okay, you realize that the beam doesn't balance, right? Okay, so let's now try it at another number. Let's try it at 9. Oh, okay. So when you try it at 9, you see that it doesn't balance as well, right? Okay, so now let's try it at the number 8. And when you place it at number 8, there you go, right? You see that it actually balances, right? So why does it balance? Okay, what can we say about the clockwise moment and the anti-clockwise moment acting on the beam? Okay, right. So if the beam is balanced like that, what can we say about the total clockwise moment and the total anti-clockwise moment? Right? So the total clockwise moments will be, if I were to take this weight as 1 unit, and this distance as 5 units, it will be 1 times 5. And then if I were to take this weight as 1 unit and this as 3 units, it will be 1 times 3, right? So 5 plus 3 will give me 8. And then on the anti-clockwise moment side, I also have 1 unit multiplied by 8 units, right? So you have your total clockwise moments to be equal to your total anti-clockwise moments. Okay, so now let's change things up a little bit, right? Okay, so if now let's say for example I want to use 2 over here, right? So I put 2 of this over here, and then if I were to just only use 1 of this, right? Just 1 of this. So over here on the right hand side, you see that there's 2 over here. Okay, so on the left hand side, in order for me to balance, I will need to put it at number 6, right? So it's only when I put it at number 6, then it will balance. So again, why does it balance? Because at the clockwise moment, you have 2 units here multiplied by 3, right? So you have a total clockwise moment of 6. And then at the anti-clockwise moment over here, or at the anti-clockwise direction over here, you have 1 multiplied by 6 to give you a total anti-clockwise moment of also 6. So essentially, they will be balanced. Alright, so that's all for me for today. I hope you understand the principle of moment, and you understand that when the clockwise moment is equals to the anti-clockwise moment, you will get the beam to be balanced. So when the beam is balanced, we say that the beam is in equilibrium. Alright, take care. Bye-bye.